The AI industry is currently split between two competing visions. On one side, massive closed models centralize power. On the other, a chaotic explosion of independent nodes promises a decentralized future through open-source weights. NVIDIA CEO Jensen Huang argues that durable technological sovereignty cannot rest on a few dominant closed models. In his view, a resilient ecosystem requires open weights to prevent any single organization from becoming a terminal point of failure. Huang's thesis is that open weights break vendor lock-in. By allowing institutions to modify and host models on their own infrastructure, they retain their specialized knowledge rather than permanently renting intelligence from a central provider. Critics of this approach warn that unrestricted weight releases unleash uncontainable systemic chaos, arguing that closed models with centralized guardrails are the only way to manage safety. But framing this as a choice between open innovation and closed control is a trap. Both approaches currently ignore the deeper systemic danger that threatens to destabilize the entire architecture. To find a path forward, we have to look past the industry debate and apply the Bridge360 Metatheory Model, a governance specification built for navigating systems under entropy pressure. Bridge360 is founded on a specific premise. Physical, informational, and social systems are not separate domains. They all occupy a single unified entropy geometry, governed by the same thermodynamic constraints. This logic rests on Claude Shannon's proof that information is not an abstract concept, but a measurable thermodynamic property. By establishing that every bit transmitted carries a physical entropy cost, the distinction between the natural world and cyberspace effectively dissolves. Because the constraints are identical, Bridge360 discards truth as its master paradigm. Instead, it measures navigability, evaluating a system by how it survives thermodynamic friction, rather than just the facts it generates. This framework validates Huang's critique of closed systems. However, it also proves that his proposed solution, unmanaged open-weight release, is mathematically incapable of providing the stability he seeks. Bridge360 uses the volatility paradox to explain why closed AI monocultures are structurally brittle. A system can appear tightly controlled at its center, while simultaneously exporting massive fragility to everyone else. A closed model provider achieves high efficiency by hoarding the low-entropy core. It keeps the proprietary knowledge and compute resources, the order of the system, strictly inside an uninspectable black box. But that entropy must go somewhere. The surrounding network of dependent institutions absorbs it in the form of opacity and vulnerability. They bear the risk of failure, while the central provider retains the control. But Huang is mathematically correct here. Institutional stability requires a plural ecosystem to disperse this concentrated entropy and prevent a terminal single-point failure. But when we evaluate Huang's solution, unrestricted weight release, we find it triggers an entirely different systemic failure. Breaking a monopoly is necessary for survival, but releasing weights into the wild without a governance architecture merely replaces a concentrated failure with unmanageable, recursive chaos. The current industry assumption is that thousands of downloadable models equal genuine decentralized power. But in a complex system, leverage is never distributed evenly. Bridge360 maps this using the 3-20-80 recursive Pareto principle. At the base, we see the 80%, a vast field of diverse open-weight variants and downstream applications. However, trace their dependencies upward and the diversity collapses. Most of those models share the same 20%, the foundational architectures and training datasets. Continue the lineage to the top, and the lines converge into a tiny 3% cluster. This is the absolute bottleneck of massive compute, foundational datasets, and chip fabrication. This physical hardware is the inescapable bedrock of the system. No matter how many models are hosted locally, the entire ecosystem is recursively determined by these upstream nodes. If a flaw or bias exists in that critical 3% spine, it will recursively and irreversibly propagate through the entire downstream 80%. Open weights do not dismantle concentration on their own. Without a governing spine, they simply hide upstream dependency beneath the illusion of choice. The fundamental flaw in Huang's vision is the conflation of openness with trust. Bridge360 defines trust not as a brand reputation, but as a revocable, scope-bounded license for dependence. It is authorized only when the behavior of a specific model version is proven to be stable. But once weights are released into the wild, deterministic global rollback becomes impossible. If a model is found to be dangerous, it is already copied and scattered across unmanaged networks. This makes path and provenance signatures a requirement. If a model is fine-tuned or quantized, and its cryptographic lineage is broken, the leakage budget spikes and the system becomes untrusted. The safe alternative is a system where each modification is logged and signed. Only when its exact lineage is verified can a model remain within a governed, stable corridor. Relying on an open model is only mathematically justifiable if that lineage can be audited. Without it, openness is just another form of unaccountable fragility. To build the plural ecosystem Huang describes, we need a constitutional architecture that combines open innovation with Bridge360's entropy governance. This starts with the 3% core, a shielded spine enforcing identity and entropy budgets. Surrounding it is the 20% adaptive layer, where researchers experiment with classified outputs. Finally, the 80% outer layer allows broad operational freedom, safely bounded by the inner rings. By protecting the high-leverage spine, we can authorize exploration and innovation on the periphery without risking a total systemic blowout. This layered design prevents both the terminal rigidity of the closed monolith and the unmanaged chaos of unrestricted release. But the final requirement for survival isn't just structural, it's thermodynamic. We call it entropy-driven altruism. EDA is a structural rule for multi-agent systems. It requires dominant upstream nodes to bear proportionate responsibility for internalizing system-wide entropy, rather than externalizing it onto the environment. This architecture replaces the open-loop logic of traditional models, which often maximize local gains by exporting the resulting fragility onto the rest of the network. By internalizing that entropy, the system functions more like a self-regulating thermodynamic engine. When these constraints are baked into the 3% core, the ecosystem gains a capacity for repair that matches its capacity for innovation. It prevents the structural rot that occurs when technology consumes the very stability it relies on. Jensen Huang's open-weight vision is necessary for resilience, but it will only endure by adopting the rigorous, truth-neutral physics of the Bridge360 Metatheory Model.